The last class, we talked about asset management. And the person that took us made us realize that there are two types of assets. The first one is fixed, and the second one is current. The fixed asset is the assets that lasts more than a year, while the assets, consumables that last within a year.
Thank you. Thank you. That's a good point. And you know that particular classification of assets came from accounting. It's from accounting, and that classification came from, and that was a good input. All right, let's get from Adetayo Adeleye. Does somebody have two devices in? Does somebody have two devices in the meeting? If you have two devices in the same room, we're going to be having this feedback. So if you have two devices, one has to be not only mute, but the speaker has to be reduced to 0. Okay, thank you, Adeleye. Go ahead.
Good evening, everybody. Okay, one of my takeaways from the last class was when he mentioned about the way we as facilities managers see assets and how the accountants or the accounts department sees assets. So when he mentioned that we might consider an asset of value currently, and the account department might consider the asset as totally useless or out of value, and that was one of the things I took away from that lesson last week on Saturday. Thank you, sir.
Thank you. That was good. James, James, are you just sitting down? Let's hear from Ramoni. Ramoni, before James.
Yeah. In the last class, what I learned from there has to do with the difference between the CMS and CAF. And the facilitator made us realize that CMMS is a subset. It's actually a part of CAFM, and that the CAFM actually has to do with it has to do with the whole of the facility management system. It has to do with the real estate and the property management. It also involves the asset accessibility. It has to do with the space and asset management. It has 6 segments actually, and it assists the facility manager to actually coordinate all aspects of the facility management. Which the CMM is a subset of the whole of the activities of the facility management. And it went further to introduce us to those software that are being used in each of the systems.
Okay, super. Thank you very much, Ramoni. All right, let's hear from James now. James Amen. James, you can unmute. You are still muted now. Okay. If you're in a noisy place and you can't speak, we can move on. Adebowale, please go on with your takeaway.
Okay.
Is James able to speak now?
Yes, can you hear me now?
Yes, your audio is good.
Good evening. Good evening, everyone.
Welcome.
Okay, sorry, I just joined the class. I was rushing from somewhere.
Okay.
I guess we're supposed to talk about what we learned from the last class, right? Okay. To the glory of God, I was able to, I enjoyed the last class, and I learned, I got to know about the asset register, the difference between the inventory and assets, and also the asset monitoring system, which is the tagging system, and like the CMMS and the CAFM, the differences as well. So it was a whole lot and a handful.
Okay.
Thank God for it.
Thank you so much. Fantastic. Adebowale. Adebowale, go ahead.
Good evening, everyone.
Good evening.
Yeah, my takeaway from the last lecture was the similarities and differences between the CAFM and the CMS. Even though they had a close relationship, I was able to separate the two of them and know the both function and how they can work.
Okay. Okay, that's very clear. So the CMMS is maintenance. The CAFM is all of facility management, including maintenance. Fantastic. Adams.
Good evening, everyone.
Good evening.
Good evening, sir.
You're welcome.
Yeah, my last take, what I understood from our last class was, aside having assets and managing assets, you still need to do more of continuous training and retraining in order to refreshing your mind and to build ideas upon the already existing ideas that you already have.
Okay, that is good. Thank you. Fatima.
Good afternoon, everybody.
Good afternoon. Welcome.
My takeaway from asset management training on Saturday was the strategy, the asset management strategy. It looks at the entire management of assets within an organization. So I took a whole lot of time in looking at the strategy, because it speaks directly to me as a facility manager, and it helps me that day. It just come to me as a takeaway because I was deep in a strategy session that I need this information. So my best takeaway was the understanding of the strategy in taking care of assets for an organization.
Okay. All right. Thank you for that. Kingsley. Is Kingsley there? Okay. Ansem, let's hear from you, please.
Good evening, everyone.
Good evening. Welcome.
My takeaway for the last class, asset management, is actually asset management strategy, the target system as well, and the mind-blowing one was the CMMS and the CAFM. I had a clear understanding on how to apply these technologies.
Okay.
The CMMS and the CAFM.
Okay. Thank you. Thank you. That was good. Isaac.
Hello?
Yes, yeah, the audio is good.
Yeah, I just joined now. I had issue with network, so I just joined now. I don't know.
Oh, we're asking for your takeaway from the last class. One key highlight you learned from the last class, which was held on Saturday.
Yeah, I think I can say two things. One of it is where you state, never say we are on it or we are working on it.
Okay.
We used to have this issue with our outsourced maintenance guys. So my supervisor used to tell him, no, tell me exactly when you are going to complete the work. So you repeated the same thing here. So I was like, wow.
Okay.
So the thing's right.
Okay,
and
thank you.
Then the second thing was customers. Okay. Though I know customers are always king, but you emphasize most on the need of never be rude to your customers, no matter the situation.
Fantastic.
Some of them are real problematic.
I know.
Thank you.
We'll change that perception. Thank you. But that was the Thursday class. But that's good feedback. Thank you. Ilyasu, Saturday's class.
Hello, good afternoon.
Good afternoon.
Yes. Basically, I learned the difference between the assets manager and the facility manager. Hello, are you with me?
Yes, I'm with you. Go ahead.
Yeah. And another thing again, I was able to differentiate between the inventory and asset.
Asset register. Okay, very good.
I really enjoy the class.
Okay,
Also try the last.
Good. Just to refresh, we typically will assign the terminology of inventory to materials, consumables, things that you put in store. And what we'll call assets, the things that you fix in place and use and account for, right? So we account for inventory, but we use them up. We use inventory to manage assets, basically. So if you use that simplification to be easier to differentiate. Some organizations still have inventory management as their asset management. So when you see such in the books, learn how to understand when inventory has been used as assets, so that if you are taking both of them together, and you are taking, whether you have machines for cleaning, mowers, Hoover machines, bags of soap and cartons of different products in the store, and you are adding them to the same list where you have your roof, your walls, your pumping machines, your boreholes, you have, basically just manage everything as one inventory. I try to discourage that as much as possible. So you separate the things you work with and the things you use as inventory, manage as a warehouse, inventory management, separate from managing the assets that you are responsible for, the things that make up your buildings, the equipment that you manage. So if you separate those two, it will be very helpful. Thank you very much. Sean. Okay, Sharon's not there. Let's go.
Good afternoon.
Good afternoon, okay.
Good afternoon, sir. Okay, I learned about 5 reasons why an organization will need a good assets register.
Okay.
I learned about that to maintain records and for depreciation for future purposes. I also learned about differences between inventory and differences between inventory and assets.
That's what I was just talking about. Very good, very good.
Yes.
Thank you.
So I learned about that, yes.
Okay, cool. John, do you
I
want
learned about 6 stages involved in life cycle of an asset.
Very good, very good. Thank you very much.
You're welcome, sir.
Good evening, sir.
Good evening, welcome.
Okay, so I think everybody has talked about everything. I'll just ask a question.
Okay, go ahead.
So for me as an accountant, same asset and inventory, they're trying to
differentiate them.
Tracy says she cannot undo what has been done in my brain. But an inventory is an asset. The difference between both of them is that one is a fixed asset, but the inventory is a current asset. Yeah.
Very good, yeah.
Now, but let's go beyond that. What I understand as inventory are those materials, products, whatever it is, I sell. So it forms part of my current asset.
Okay.
Now, for where I am right now, I could have bulbs, saddle clips,
yes,
cables.
Yes.
I could have all of these in store. For me as an accountant, they are not my inventory. But the facility manager will say they are his inventory.
Yes.
Now, at what point how do you differentiate this? Because I need to make Tracy understand that.
Okay. Okay, that's a good one. So the thing is this, while it's important to use the same terminology in the organization between the accounting function and the FM function, it's also critical that we separate the documents. Even if accountants have created an asset register, The FM can only use it for reference purpose. They have to create their own asset register. I've seen many FMs go and grab the asset register from procurement and say, here's our asset register. It is not the same document. If you look at the list of information that should be provided for every asset, the accountants are not interested in how many kilowatt hours, runtime issues. They're not interested in most of the details that we have there, useful life and the rest. They are interested in how to write off that asset in their books and how to account for it when they spend money on it. Exactly. So they are mostly interested in the depreciation amortization aspect of asset life cycle, while you are concerned about the use of the assets. So always ensure that you have your own separate, asset register that is more detailed, usually more detailed than that of the accountant. Now, in terms of your inventory, the FM maintains his inventory as the items he uses to work. His inventory are usually his materials and consumables, okay? They are kept in a store and is used up from that store. That's the FM's inventory. Whereas the roof, the borehole, the generator is an asset for that FM. He uses some of the items in his inventory to maintain and manage the assets. So while he's using up the inventory, he's maintaining and managing the assets. He has to be, yes, he needs to be increasing the value of the assets while consuming inventory. So
not necessarily that the inventory is used to generate.
No, not necessarily. Exactly. So for if you now have a supermarket, for example, as your business, right? There will not be two different inventories. The core business inventory managed by the core business accountant is the goods that are being sold in the shop. The FM of that supermarket will still have inventory of his cleaning supplies and his diesel and his cleaning materials and his fumigation chemicals separate from the inventory of the core business. They will be the same word, but they will mean different things.
Okay. Okay.
Thank you.
Is that right? Thank you.
All right, good. Okay, so let me ask if anyone else feels there's something that was important about that class that had not been mentioned. I don't want us to go repeating what someone else has said. So I'm just going to throw that open for 2 or 3 people to give me their takeaways that have not been mentioned so far.
Good afternoon.
Good afternoon. Rayami, go ahead.
My name is Shobanke Shakiro.
Oh, Shobanke. Okay, sorry. I thought it was Rayami that already sounded. Go ahead, Shobanke.
Sorry, what I took from last Saturday is a bit different from others, for 50% similar. The tutor mentioned very cogent thing that I picked. He mentioned categorization of assets in terms of value, in terms of purpose. The way I classify my assets in a maintenance company is different from the way it's being categorized in hospitals. It's different from other. It depends on purpose. You mentioned purpose and function. So we may have the same assets, but we give priority based on cost and value and purpose of their assets.
Sure.
You mentioned life cycle of assets, and you mentioned one acronym, BED. I mean, a bet of assets, life of assets, and the debt, which is disposal and the rest. Like I'm hearing it for the first time, I was so amazed. So a fresh memory, which knowing this, I know it gave me opportunity to know everything about life cycle of assets with the acronym of BED that they gave to us.
Okay, that's good. That's very good. Thank you so much.
Also, the point for asset manager and facility manager, I'm looking at it's like the more facility manager embark on predictive maintenance, it will be to the asset manager.
Not quite. So let's not confuse asset manager, facility manager, right? An asset manager is a function. It's a function that are performed by 2 key professionals in the organization. The facility management professional they have their asset management function. The finance and account professionals have their asset management function. Okay. Now, if an organization decides to appoint asset managers, they will either be somebody in the accounting team or somebody in the FM team, or in some cases, have an FM asset manager, also have a accounting or finance asset manager, right? So if you are managing your facilities as a professional facility manager, you are automatically the asset manager of that facility. Unless there is now more specialization that requires you breaking out some part of your function of asset manager to another person to handle under you.
Okay, Mr. Paul, in our organization, we have a unit called fixed asset team.
Yes.
So these guys, once you are maintaining AC after 4 years, they'll be telling us, go and card it. It's off the book. But we may be saying that this is still serving. So at a point, we normally have be as loggerheads struggling with something.
You see,
when we have
you see, those guys are accounting, those guys are accountants and finance asset managers. Those assets have been written off in the finance books, and you are still spending money on maintaining them. That's why you are having that conflict.
Okay. Best ready to discharge and follow them, or what do you think?
So what you now need to do is do a business case, right, to justify your continuous use of those assets. That's one. And to do that, you need to prove to them that the useful life of the assets is longer than they estimate. Many of them are using a flat rate of 4 years for air conditioning, for example, right? And ACs of 8 years are still very functional. You can make a case to get them to extend their own life cycle amortization ratios for those equipment to more than 4 years, so that you guys can be in sync.
Okay,
yeah.
That's fine. That's good. Thank you.
Thank you very much. Olayemi.
Yeah, good afternoon, sir.
Good afternoon, welcome.
Good afternoon, welcome. Thanks, sir. So what I just want to say is just a suggestion. I want to suggest that like the asset register and the inventory,
yes,
maybe in the presentation, we can have samples, just maybe like 2 or 3 lines, just to show example of what an asset register looks like, so that it will be easier for people to, to follow.
Okay.
Although I know that a lot of headings are listed in the columns, but when people see types and then the way they were structured, it's sort of help in easy assimilation and then following the example.
Okay, I told you that one of the projects you'll be doing is your asset register.
Okay.
So I'm going to ask the training team to give you the project docket, so you can see the templates and the example of an asset register. You can modify it as you want, but we'll just give you the basic templates, okay? And then if you look at your slide, there are at least a couple of slides that talks about the things that we track as inventories and the things we track as assets. And then there's another slide that talks about some 16 to 19 items that an asset register should contain in terms of what it describes, how to describe the various features of the assets. So yes, you get a template.
So yes,
you get a template
docket. Okay, thank you.
Thank you. All right, so we'll go straight into a solution session now. We can spend a few more minutes on a solution session. What work challenge can we solve for you today? From any topic, from any aspects of your experiences this week. That's where we are now. If I see your hand up, I'll give you a chance to drop a problem, and then let's solve that quickly before we get into today's class. Are we still dealing with work from home offices where everything is locked and we are not yet unwrapping? I know FMs have challenges with reopening of offices that have been locked for a while. So if you have such a challenge, you can pop it up. Let's hear from Kingsley first.
Good afternoon, everyone.
Good afternoon.
Yes, my questions are challenge I'm having presently at the workplace is how to track diesel consumption. We have a 1,500 tank. That's the size of the tank, diesel tank. And we have a different generators, the 80 kV and the 100 kV, both sucking from the same tank. Now, the diesel that was supplied, we had the whole tank filled up, and everything got finished in less than 72 hours. And everybody, all the management were throwing questions at me, what happened, why we've not had this happen in a long while.
Yes.
What's the problem? The generators are still quite new. They're just barely less than 8 months old. So we needed to explain to us that the density of the diesel that was supplied was not what we normally have. So my question now is, how do I know the density of the diesel to accept? Because I think one, I was suspecting the meter reading, maybe their meter is not, it's kind of faulty, or maybe there's something they did to it. So I want to know, how can this be tracked?
Oh, wow.
So that I won't have to run into this.
Yeah. So first, Kingsley, you have quite a lot of things to take note of. I'll just be dropping them for you. If you have a pen, you can be writing down.
Yes, please.
There is need to have diesel testing before you receive. Your diesel must be tested. There are two key tests. There's a basic density test, which is the one that uses a hygrometer. You drop a little diesel inside it and there's a bulb. And then it has a range marked on it that says if it is within this range.
Hello, the network seems to be bad. We can barely hear you, sir.
Oh, you can barely hear me. That's interesting.
Yes, sir.
Who else is having the challenge of hearing? Okay, let me put up my video temporarily and see how that helps. Okay. 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 How about now? My audio better. Okay. Okay.
Yes.
All right.
Yes.
All right. All right. So let me give you my fine face on that picture for now. So the first thing is your diesel needs to be tested using the density test, and then there is also the quality test. There is a certain cream you put on a deep stick to dip into your diesel, and that dipstick is to catch if there is water mixed with your diesel, because when guys come to deliver diesel to you, they might just add some 100 liters of water to 5,000 liters for a quick buck, right? So at the price of diesel nowadays, 100 liters is a lot of money in the guy's pocket, right? So you need to check for the density and then also check for water content. Okay. There are simple things you can have. The cream one, you can buy them. I'm not sure they're very expensive. Few hundreds of naira. You keep it, rub it on a stick, dip it in the diesel tank. It changes color to show whether it is okay or whether there's water, right? And then
Will this be done before they supply or
as they come, as they arrive, before they deliver.
Okay.
So that if it's a negative result, you don't take that diesel. No matter how desperate you are for diesel, don't take a bad diesel. That's the first thing.
So what I'll do basically is just to get them a 10 liters for them to pour in.
No. They just need a small cup. Just a very little diesel you need for both tests. For the first test, it's just a little in the cup that goes into like a test tube where you test for density. Then for the water content, they will have to allow you to dip your stick into the tank.
Okay.
Okay. Once you rub the cream on your stick, you dip it into the tank and bring it out. It tells you whether there's water or not. Right. That's the first thing. You test your diesel. Secondly, and this is very important, ensure that you have your own meter for receiving diesel. Never, ever rely on the supply meter on the truck that brought diesel to you.
Okay, so
never, ever rely on that.
That means you buy a device, a meter device?
Yes. That same line where they connect their hose to run their diesel into your tank, you should have your own meter there. Okay, so when they know that you have your own meter, they will most likely not play any prank at your site. They won't do anything funny. All those adjustments of meters will not be happening because they know you have your own backup meter. If the discrepancy is very little, less than 0.01%, for example, you can say, okay, and maybe we didn't calibrate, you didn't calibrate, or I didn't calibrate. But if it's up to 0.5, for example, or 0.2% even, you can't take that. Discrepancy is too high. You need to say, no, I'll stick with my own meter. And most of the time they will agree with you, they will stick with your meter to buy. Now, that's point number 2. Point number 3, you need to have a logging of the quantity of diesel consumed by each generator from that tank, such that you have the hours run of each of the generators, which are being logged, and then you have the diesel that matches the time, the hours, or the time run by the gen. So if a gen runs for 5 hours, for example, you also want to know that in these 5 hours, this is the amount of diesel consumed, yes. So because your generators are connected directly to the tank, and we actually advise that you don't use your base tank. Don't use base tank for generators. Base tank is the one you have to pour diesel into the tank of generator to use from there. That is susceptible to all kinds of corruption in the sites, right? So you meter that, you pipe directly from the tank like you have done into your generator, and then you make sure your inflow and return. Most large generators will have a return line, right?
Yeah. Yes.
The inflow and return will run through the same meter, such that the meter can discount the return while accounting for the inflow. So you know exactly what is being consumed. And I would normally recommend that you use a digital flow meter for this purpose. Digital in the sense that you can have access to it even beyond going to look at it to read it. You can have, remote access to that flow rates, and they are not very expensive these days. There are so many digital metering solutions now that you can install. In Lagos here, you can get some tank set up for less than 300,000, and you have access to your diesel inflow and outflow round the clock, real time. Okay, so you need to also monitor that. We even have systems now that we can connect to your, we connect between your diesel tank and your generator that tracks diesel consumption and matches it against the generator running hours. So I can actually tell when my generator is consuming unusually high diesel for the same hour. So if a diesel generator that normally consumes 30 liters per hour is consuming 35 liters per hour, I will know that real time. I will not wait to start, long stories. I already know now that this generator is consuming more per hour because I'm seeing that data on real time. So if you need any of such solutions in your site, if your diesel consumption is becoming problematic, you can consult the Max-Migold team, and they will share with you some technology that we help to carry. And then,
very helpful, sir.
Yes, it should be. Once you are able to get that in, you now have visibility on how your diesel is being consumed. Then the last thing, and this is also very important, we should have a metering for the power our generator is producing, the power that is being drawn from our generator. So while you do all of those check meters for your public supply, check meter for your various clients, and so on, also have a meter that meters the electricity that is producing. Many times sometimes you get into a situation where you now need to quantify how much your cost per kilowatt hour is when using generator. If you don't know how many kilowatt hours you're actually producing from that generator, you cannot tell how much your cost per kilowatt hour is, even if you know the rating of the gen and you know the runtime of that generator, because the gen production at any particular time is dependent on real-time load, not on its rating. So a 1 kVA, 1 kilowatt generator, for example, can be doing 250 kilowatts while it's running. And there is a relationship between the load on it and the rate of diesel consumption. So while you are looking for where your diesel went to, you might also find answers in the load that was imposed on the gen at that time. Okay, so if you don't have this data, you can't make educated, information or decisions regarding why your generator is probably consuming too much. And finally, while you are tracking all of this data for the generator, you must also be tracking this data for the main supply. What this means is that you must know exactly when the public supply came in and left. Okay, so you are tracking those hours because that is what's going to tell you what's happening to your generator. If your gen is going to be running a lot more hours because the public supply is not more consistent or is failing, you should know. Sometimes you are managing a site where the public supply can go off by 12 in the afternoon. You are not obliged to put on generator till 7 p.m. So tracking just when your gen comes on and not tracking when your public supply goes off as well can give you information data gap. So you need to track both, even if you're not doing automatic changeover and moving into generator immediately power goes off, okay? Just a few tips. When you are taking the electrical class, the power electrical consultants will do a lot more about throwing more light into how you can manage your diesel. But importantly for facility managers, you must be able to account for every liter of diesel. You cannot be blindsided, exactly. So you can explain to management. But that's our law.
This summer, you start conniving with diesel suppliers. How come?
Exactly.
Thank you very much, sir.
Thank you.
I think I need to come up with this. If I can put this in my next report and send to the management, I should be able to get it to be vindicated.
Right, that was a good one. That was a good one.
Thank you, sir.
All right, thank you so much. Shakiru, is it a solution session you want to stretch? I think our solution session we're taking one, or you just have a question?
I want to add to your explanation to the last caller.
Okay.
In my organization, the guys are so smart. On diesel tests, they beat us on that because on diesel tests, density tests, and dipstick, because they beat us. They use kerosene, diesel, and black oil. When they use density, with our density tester, we got the density, we got the viscosity, but what they supply is not so, it's rubbish. So we change the supplier. All our apparatus to test them, to catch them, fails. So we change the supplier because generator has certain consumption power. That's for a press generator, there's certain volume of diesel it should consume. And if your generator is behaving outside the range, change your supplier because definitely kerosene will vaporize. Because it has higher viscosity than kerosene. So you to change your supplier and check. Also, you need to check leakage.
Fantastic, fantastic. Thank you for that. That was a very good best practice we've learned from Shakiru right now. Thank you very much for adding that. All right, so I'm going to just yes, of course, the classes are recorded. The classes are recorded. You all have access. We give access to the videos of each class to everybody who's not owing any fees, okay? Once your fees are settled and you don't have any outstanding requests for access to the videos. It may not be the video of the current class, maybe the video of previous class, which will give you, double advantage. You get multiple perspectives to the same topic. All right, I believe you're seeing my screen. I'm just going to give us a 2 minutes break, or let's say 3 minutes break, and then we'll get straight into today's topic, all right? Okay, welcome back. Today we are looking at maintenance strategies. Many of us start our careers being showed what to do. And one of the primary activities we encounter in facility management is that of maintenance. But the way we are showed how to manage maintenance is mostly what to do. This is the asset, this is what to do, and this is how it is done. So we learn almost by rote. Whether we learn through apprenticeship, observing others, or reading the manufacturer's manuals, every time we learn what and how, without knowing why those whats were specified and those hows were specified, we are always going to come short in terms of our understanding of what we are doing. So we are unable to make adaptations. We are not agile in our applications. We are not flexible in the way we do the things we do to give better results. We are not able to work with different approaches to give the same outcome. We may often end up with certain activities overdone at the detriment of others. And sometimes the results we get will not be as predictable as we expect. Because when you expect a very good result with a certain maintenance approach and you're not getting it, you get kind of disappointed. But then all you know is what to do and how to do it. We're going to leave what to do and how to do it about maintenance aside today. And we're going to elevate ourselves up to why we do those what's and hows. That's what we're going to be looking at in maintenance strategies class. All of the things that you do and how you do them will become clearer. You become more able to take decisions on how to make adjustments, how to take precautions, how to ensure that you get the best results that suits the outcomes your organization or the demand organization wants from the use of those assets after you've gone through to this class on maintenance strategies. In this class, we'll be looking at 3 key strategies that can be deployed in maintenance. There are 3 key strategies. You might read several textbooks that will talk about all kinds of breakdown of strategies, but in facility management, there are 3 key strategies, and they are run to failure. It is a strategy. Run to failure is not as it sounds, something negative. No, it's a very, very sound maintenance strategy, often called reactive maintenance strategy, also called corrective maintenance strategy, emergency maintenance, and so on and so forth. It is that strategy that is deployed when we do unplanned maintenance. So primarily, there are 2 types of maintenance: the planned and the unplanned. Those are the 2 types of maintenance. The unplanned feeds out of one strategy, which is called the run to failure strategy, or the reactive strategy, or the corrective strategy. Whatever you call this strategy, it is the main strategy that every unplanned maintenance is based on. The second type of maintenance, the planned maintenance, has 2 strategies that feeds from it. The first planned maintenance strategy is the preventive maintenance strategy. And the second is the predictive maintenance strategy. So in today's class, we're going to be looking at the features, the advantages of each of these 3 strategies that break out from the 2 maintenance types. And then we're going to be wrapping up with reliability-centered maintenance. On its own, reliability-centered maintenance is not a maintenance strategy. It is a maintenance philosophy or framework that guides how you apply any of these strategies in your various assets, looking at your maintenance as a portfolio. What this means is, reliability-centered maintenance does not look at individual assets or components of assets, but rather looks at a combination of assets that make up an asset portfolio and prescribes the rules with which you apply any of the strategies of run to failure, preventive, or predictive. So if I have a typical building, for example, and the building serves as my training school, I want that building to always be able to accommodate students When rain falls, the building should be standing firm. Rain does not come in, the air conditioning works, the building should be functional in itself, in all, right? And I have probably 90 or 100 assets that make up that building. So I have the roof, the ceiling, the lighting, fittings, I have the air conditioning units, I have the floors, walls, ceilings, you know, I have the boreholes and so on and so on. These are all individual assets. When I adopt a strategy for maintenance, I adopt it for individual assets. So what strategy am I going to adopt for the roof, for example, as against the one I'm going to apply for the generator? There may be different strategies. That's what I'm doing at asset level. Asset by asset, equipment by equipment, I am dealing with specifying one maintenance strategy that will guide the what's and hows. It is because of that strategy that has been adopted, I will now know what activities to perform and how to perform them when I'm doing my maintenance planning. Okay? Now, in reliability-centered maintenance, I'm now looking at making sure my entire asset, my entire portfolio of assets in that facility is functional and gives me the highest reliability at the lowest possible cost. Okay? So when we talk about reliability-centered maintenance as the economics of maintenance, it drives home the point that you cannot just spend because you need to maintain well. You need to consider the value, what we call best value, the value you are getting for the spend, for the amount you are putting in, and the reliability, or what you are getting in terms of utility from the assets compared to the amount you are spending. What you really want is not to spend anything extra above the amount you need to spend to get your assets functioning at the state and condition you want it, not more. Okay, so we'll talk about that as well as we go on into this class. So what's the objectives? What are some of the objectives of maintenance strategy? You want to ensure that your assets are available when you need them to be available. You want to ensure that your assets are safe, that they can be operated safely, and that they can be used safely. Downtime is usually something you want to avoid. What downtime does is it takes away functional period or time from your equipment or assets. And downtime could actually come about because of the maintenance program you put in place, where you have to take it out of circulation or out of use to maintain frequently, or let me say maybe too frequently, right? So your best bet is to have minimized downtime. Downtime could be from disruption or scheduled downtime from your own activities. You also want to have your equipment reliable in the sense that the equipment should be able to respond to your need at any point in time, not having the fear that is going to disappoint you. Your cost and time of maintenance needs to also be managed. You cannot, spend too much time or spend too much money doing maintenance. And that's why you need to ask yourself, what strategy am I adopting? How can I adjust or change this strategy? And how will that impact what I'm getting out of these assets? You want your assets to perform optimally. You don't want them to break down or require upgrades too quickly, okay? There are some assets that are actually too complicated that when you begin to see them fail too quickly and require upgrades too quickly, you'll be spending a lot more than you can imagine you will need to spend to run your facility. And then you also want your equipment to work and provide results, be productive through its useful life. So while we typically say maintenance does not extend useful life. Poor maintenance, wrong maintenance, or no maintenance can shorten useful life. You specify your useful life and you do maintenance to ensure that your assets can live productively through to the useful life you specified for it. And then you reduce unplanned downtime. So downtime could be both planned and unplanned. Your maintenance strategy will require you to understand the methods of each strategy, the goals of each strategy, the advantages and disadvantages of each strategy. And mind you, because you are talking about adopting strategies per assets or equipment or components, a strategy may not be positive in terms of results for one asset, whereas that strategy may be the best strategy for another asset. Okay, so we're not going to use a blanket, cover for all assets and say this strategy is the best. No, every asset will need to consider the things you're getting out of the asset, the what we call the failure mode of the assets. There are some assets that have some moving parts, a lot of friction. So the failure mode will be different from those which are static and not dynamic. Then criticality of the assets. Does life depend on this asset working? Is there a high risk of safety incidents or injury if this asset does not operate optimally, and so on and so forth? So it's important to understand all of that from the organizational point of view before you start trying to relate the strategy, because the strategy is adapted from what you understand you want to get out of the assets. So the organization's use of the assets, the purpose of why the asset has been acquired, and so forth must be considered. How critical that asset is to the organization before you start looking at the strategies that will be more suitable. Okay, so we'll look at the various strategies we can adopt in managing the various facilities or assets that we have. It's important that there's a good understanding of how equipment fails in order to make a good choice of the most appropriate maintenance strategy for your facility. Okay, so when we have finally gone through the various strategies in this class, at some point you will now need to take your entire asset register, look at every of the assets you are responsible for maintaining, and begin to select and adopt different strategies for each of the assets. And you have to consider certain criteria. For example, the resources you have. How skilled are your team? How many people do you have on ground? Do you have access to vendors, for example? What about your organizational maintenance process? Are you running an organization where there's proactive, budgeting and resource fund availability for maintenance, or you have to take every maintenance activity back up for approval and so on and so forth? Some strategies will not work depending on how your maintenance process works. Do you also have a standard operating procedure or something like a playbook that gives guidelines on how things are done? Some strategies will work very well with a very structured environment. Some strategies will do better in a system where you have to figure things out as you go. What about the technology? Technology for managing assets in terms of the CMMS and the CAFM software we talked about. Also technology in terms of the kind of assets we're managing today. You see buildings are becoming smarter by the day. New systems are coming on into the built environment that we need to start getting ourselves aware of, because when it comes to maintaining these assets, the more sophisticated the assets or the facilities become, the more sophisticated you, the facility manager, needs to also become, as well as the tools that you have on hand to manage the assets. Technology costs, type of equipment, personnel skill, personnel training, quality of service. Sometimes the customers have very peculiar tastes or needs that must be met. For example, you are serving a hospital, right? The hospital could make do with 30 minutes changeover time because the technician has to go from one end of the site to the other to go and do manual changeover. But when it comes to theater rooms, for example, the hospital cannot make do with that kind of break in power supply, right? So you need to understand the type of customers, quality expectations of the customers before you can decide what strategy to deploy. For the one that can wait, of course, I will not need to spend money on automations and stuff. I just get my staff to go there on its leisure and do the changing over, for example, compared to the one that cannot even manage a 2 minutes break. I'll have to put some kind of UPS inverter system or automatic startup generator with an automatic changeover for that particular client. Okay, so the maintenance strategy will have to be different as well. What are some of the common challenges with deploying maintenance strategy? Many facility managers, like I started with in this class, have not had time to be taught, have never been taught about maintenance strategies. And because they've never been taught about maintenance strategies, they've lived their whole careers doing the what's and the hows without ever considering why. So because of that, there's lack of understanding on the components of maintenance strategies. Sometimes our senior management in our demand organization and client organizations might also have a difficulty understanding deployment of strategy. For example, why do you want to have funds allocated that will not be spent on an ongoing basis? They're just allocated and left in the budget for when things will break down. There's a strategy that demands that you do that, but that doesn't make economic sense to management in most cases, because as far as they are concerned, that is like tying down funds that could have been busy doing some other thing, right? And the FM himself does not understand the implications of what it means to management when they say this fund is being tied down. So the FM may be arguing on one side, and management is saying, no, we're not going to oblige on the other side. What you need to do as an FM is try to understand management's point of view, but also present the facts of the matter, because you have data that shows that when these things suddenly fail, it causes disruption that is going to cost us a lot more in terms of productivity of the core business than what it will cost us to put funds aside to anticipate it. And if the asset in question becomes too critical that we now feel that that strategy is no longer working because there's a lot of management resistance to keeping funds for it, we cannot switch it to a preventive strategy. We'll talk about how to move your assets between strategy when we get to the ROCM section. And then sometimes you have maintenance strategy, but you have ineffective maintenance planning. Or it's even possible to have a very sound maintenance plan, but you do not have execution of that maintenance plan. For example, you have a maintenance plan that rolls out a certain series of activities that must be performed, but you are not tracking the performance of that maintenance plan. What that means is that whether the activities are done or not, you don't have a record. Whether they are done on time or not, you don't have a record. You don't have a record of those that were not done at all and those that were done unsatisfactorily, right? That could lead to a lot of complication because there will be a lot of data requirements to justify your investment in maintenance that you may not have the data for. And then sometimes maintenance strategy may completely be misaligned with the strategy of the organization. If you are the type that likes to do everything planned, programmed funds spent every day or every week on a continuous basis. You might be in an organization where the management prefers that you deliver those results and pay your vendors later, 45 days, 30 days, 90 days. And so the FM needs to understand how to adapt strategy to align to the expectation of management, especially when it comes to financial metrics. Even customer service metrics, for example, can be a big blow for some organization where the FM is trying to do a particular maintenance task because it is due according to the strategy and activity plan that he has, but that maintenance task you want to perform is becoming an encumbrance on the smooth operation of the demand organization, or is becoming a bottleneck, so that people have to, at some point in their day, take a break, a compulsory break, because the FM needs to carry out a certain maintenance activity. If the organization, if you are not able to quantify the cost of that break to give you a sense of what you are doing to the organization, you can easily be singled out or picked out at some point to say your maintenance is becoming a nuisance factor in this organization, okay? So you have to have alignment. People need to be productive, need to have a sense of well-being, but we cannot use our maintenance to obstruct that overarching goal of the organization. And then maintenance planning. Many of us have what we call a PPM, a planned preventive maintenance plan or program or activity. Now, that document, I dare say, that document is not adequate because it is a document that only accounts for 1 out of 3 possible strategies for your entire portfolio. So anything that is not going to fit into that one strategy, which is the preventive maintenance strategy, will not find itself in that maintenance plan. So in essence, you are not having a plan for things that are not going to be preventively maintained. Okay, so I'll tell you upfront and straightforward, scrap preventive maintenance plan and create a maintenance plan. The idea is to have all of your assets in front of you on a daily basis. The items or assets in your asset register that do not require daily routine activities, they will be there. You will still be seeing them. You will still be knowing certain considerations that you need to have regarding them while you are dealing with those that are under preventive. There will even be some that are going to be under predictive maintenance. So your planning is inadequate if you do not have it robust enough to accommodate your entire portfolio of assets, which means your asset register is your template for creating your maintenance plan, and all of the assets being assigned a maintenance strategy before you begin to go into the planning. It is only after the strategy has been assigned to each asset, you can now say, now let me design the plan of activities for this particular assets. Maintenance goes hand in hand with an organization's objectives, and so there must be a clear understanding of maintenance objectives to ensure proper allocation of maintenance resources. In essence, your maintenance cannot be at loggerheads with your organization's objective. So you understand the objective of the organization, and you are creating objective for maintenance that helps you align maintenance to fulfill the needs or the requirements of the objectives of the organization. All right, so let's take a look at the first strategy. It is the simplest and most straightforward of all the 3 strategies, the run to failure strategy. Is the action you take to repair equipment after it has failed or a fault has been identified. So we here might see an air conditioning not working as failure points, whereas if you really look at the AC, you don't necessarily need to wait until it's no longer cooling before you know there's a failure point. If it is now making noise, shaky fans, now dripping water, for example, now all kinds of, or heating up, you already see a failure. A failure, in line with this strategy or this definition, is any operation of an asset that is a malfunction. A malfunction is described as a failure. A malfunction is an irregular or non-functioning scenario for the assets, okay? You restore the equipment back to intended function, which means you repair, you rekit, you refine, whatever. What you're basically doing is you are taking some actions to correct it from that error mode, from that malfunction mode, from that failure mode, back to functionality. Often very cost effective for small equipment. Can give you for free examples that we can consider, small equipment, like your light bulbs, for example. There's really no other maintenance strategy that is more suitable for your light bulb. It is just allowed to blow out or go dark on one end, or start becoming dim or start flickering or something that tells you I need to do something about it. So there's really no other strategy that is best for it. Okay, and I can tell you, more than 90% of the assets in your asset register today will be most likely suited for run to failure maintenance. Tell me what maintenance you can put in place for your desktops, tables, and chairs in the office, for example, or your doors, or your toilets, or your walls and wall finishing, or your windows. Basically, nothing. You are conscious of them because you have assigned a run to failure strategy to them, and you have made provision for resources to ensure that when they do fail or manifest a fault or malfunction, you can deal with it. It's also very applicable for very costly or complex critical equipment. Take your high tension synchronization panels, for example. Do you really want to be opening up those things to do maintenance in the back end? I doubt. They are very sophisticated, very complex, very expensive, and if you make one false move with them, you might have your entire career and organization redefined. So you let them be and only monitor them for when faults arise, and then you fix them. It also helps to handle when you have situations where you have redundancies. If I have 2 or 3 pumps, for example, all networked into the same water production system in my facility, such that it is one pump that works at a time. When that pump fails, I can change the valve directions and activate the next pump and take the first pump out to go and repair. I don't need to put any kind of maintenance in place for any of the pumps because I have N+1, N+2, which means I have first redundancy, second level redundancy for that particular asset. I see some critical assets that are core to the mission of the organization that can be run with run to failure, for example, because you have redundancies. You have a massive server that serves the organization. There's concern about the FM's team coming into, the FM teams coming into that server room because they could mess with things and push cables around that will lead to all kinds of issues, right? And because of that, management has decided to provide 3 equal capacity air conditioning systems for that server room, whereas 1 is what runs the server room. If you have provided 3 systems that operate 1 at a time and cover the capacity of that asset, why do I want to use another strategy to maintain those assets? I'll use run to failure, even if they are critical assets, air conditioners, for example. I will use run to failure. Why? If one of the air conditioners develop a fault, starts making noise, starts dripping water, starts warming up, I simply switch to the next,
I don't go before class.
presenting a fault out for repair. So that's the whole idea. I focus heavily on not doing maintenance on a routine basis, but doing maintenance or repairs when it presents with a fault, because I have redundancies. Reactive maintenance has a philosophy of repair equipment when it breaks down. If it doesn't break down, then don't fix it. Reactive repair is basically identify what happened, do some kind of root cause analysis of the problem, isolate the problem, fix it, and recouple and start using your asset again. So situations when it should be used, complex maintenance procedures. If some of you have seen these electric sewing machines, for example, or even your automatic watches, you find that it has so many moving parts, tiny parts that are held in some very delicate balance that you don't want to go, touching them. In fact, in the case of the electric sewing machine, it is actually immersed completely in oil, 24/7. Because you can't go and say, oh, let's put some grease here, let's put some oil here and there. It has to be fully immersed in oil and used continuously until it manifests a fault. And often that fault will become obvious. You begin to observe such faults when the equipment is running out of oil because it's beginning to work in conditions that it's not comfortable with. Okay. Some other strategies will be expensive. Other strategies will require certain routine activities. There are some assets that you cannot justify having routine activities being paid for just in the name of maintenance. So it becomes too expensive as a strategy. So you use run to failure. I mean, think about it. Our roof that we have in our facilities, if you had somebody coming to climb on top of the roof every week or every month to do some fine tuning and do some lubricating and stuff on the roof, you can tell, just from hearing that roof will probably go bad in a short while because of too much activity on top of it. And also, you're going to be spending so much because of the cost you'll be paying to those who will be coming in to do those maintenance activities. Easy to replace components would typically run with run to failure, things like light bulbs, toilet handles, and things like that. There's no need to maintain them outside when they have a fault. And then equipment failure has minimal impact. Okay, so you have a floor, for example, you have tiling on the floor, and there's a crack on one corner of the floor. I don't necessarily need to be coming to apply glues all over the floor, doing any maintenance on a routine basis, apart from normal operations cleaning, just because I want to prevent that floor tile from cracking, right? So if it fails, my business will still go on. Everybody's job will still be running, even without, even with one missing tile from the floor. So when the equipment failure has minimal impact, then of course I don't need to worry about having another strategy. And then that also feeds into the redundant assets. Okay, so when you have redundancies in place, you don't necessarily need to do anything other than run to failure. Reactive maintenance strategy is actually present in all maintenance strategies, as failure is not perfectly predicted, and also equipment still break down even after maintenance action has been performed. Now, this is not to say that when you do not plan, you do not apply a strategy, you do not have a plan that comes out of that strategy, your equipment fails, you have automatically moved into reactive maintenance or run to failure strategy. Wrong. Okay, or that you have done your preventive maintenance and you failed in some of the activities and your equipment starts breaking down, you start doing repairs. That does not change your strategy. Your strategy is a conscious decision of allocating why you do certain activities for that asset. So if at the end of the day, your strategy was preventive or something else, and you could not implement it and things start breaking down for you to fix, don't mentally recalibrate yourself to say, we are now running to failure because we are no longer doing preventive. If you think that run to failure will be a better strategy because of the circumstances you find yourself in the organization, then go back to your maintenance plan and change the strategy so that all of those activities you were supposed to be performing that you have not been performing will be deleted from the activity plan for that particular asset because you have changed the strategy. What are some advantages of the run to failure? Minimal staff requirements. So you don't need many people to staff a run to failure operation. Initial low cost, because you're not going to be performing routine activities on an ongoing basis. It gives you that, somewhat of an illusion that this is a cheap form of maintenance until you suffer a failure that gives you two cost elements to deal with. One is the increased cost of fixing things, and the other is the loss of productive use of that asset due to unplanned downtime. These directly feed into the disadvantages of the run to failure. So why it may be the perfect strategy for my walls and ceilings and my roof or my floors, it will probably not work for my generators or my air conditioners. All right. I need to be sure that I do not use a strategy misaligned with the various assets I have. Moving on to preventive maintenance. This is maintenance performed at a scheduled interval. That interval could be runtime, which is the equipment running hours, often metered in the case of photocopiers, printing machines, and generators. Or it could be a time interval, or what we call a periodic interval. That is the kind of activities you perform on a weekly, monthly, quarterly basis. These maintenance that your preventive or preventive maintenance does not have any consideration for equipment failure. It doesn't matter whether the equipment is fully functional, partially functional, or just barely surviving. These maintenance activities that you have planned, you will be implementing them on your assets. That's why it's called preventive maintenance. You are doing it irrespective of equipment failure, okay? Not that you're going to do a plan, a preventive maintenance on an equipment that is not in service, for example. As far as it is in service, you keep, providing maintenance activities, following a routine set of activities at certain frequencies. Okay, that's basically what you are doing for the preventive. Preventive maintenance seeks to reduce unplanned downtime and repair costs, but it may not always detect failures before it occurs, since the approach is not condition monitoring. It focuses on performing pre-scheduled activities. That's what it does. Okay, so it's not condition monitoring. Okay, so what are the features of preventive maintenance? You want your equipment to be reliable. There are certain standards prescribed by industry and standards prescribed by the manufacturers. There are certain things that you must have in place, like replacement parts. You must know the components of the equipment. You must have a recording system for recording the maintenance activities that are performed, so that you have a history of the what we call the maintenance history of the assets that can be used for decision making in the future regarding repair, replacement decisions on that asset. The advantages, it reduces the risk of unexpected equipment failure. Okay, so that's why we typically see the preventive maintenance strategy as the safest approach for many of the equipment with moving parts, for example, and critical equipment, according to the priority or ranking of the equipment for the organization that we are working. And then we want to ensure that downtime, because we're planning this particular this particular maintenance strategy, we want to ensure that the maintenance itself does not lead to unnecessarily high volume or level of downtime. Okay, even though it is supposed to help you reduce the incidence or likelihood of unplanned downtime, you might use this strategy to create downtime that are planned, which will be detrimental to your facilities value to the organization. And again, preventive maintenance has a way of supporting your health and safety goals in that you basically, prevent the equipment from failing or from becoming harmful. And it typically has some level of cost savings compared to reactive maintenance or run to failure. Now, this cost savings may not be in terms of maintenance cost only. It's also in terms of productivity losses, because your maintenance is not just the cost of the maintenance, but everything that is incident to that maintenance activity. So the cost of downtime, for example, and everything else that go into that maintenance is part of your cost. So what are some of the disadvantages? Higher demand for resources. You have to have people on standby for preventive. There are also a lot of maintenance costs built up because of a routine, regular schedule of attention and activities. And then, of course, you're not considering the technical condition of the assets. Parts that are functioning will be replaced. We are in this industry, we take out oil and the oil seems to still be useful. We'll take out filters and we'll take out other replacement parts because the prescription is that they should be removed and someone else can still put them back into his own engine and get value out of them, okay? Maintenance activities may not be prioritized because this is the what and the how we are dealing with. We often will just be doing maintenance activities that are in the books without thinking of how to prioritize them or any flexibility. Equipment will still fail anyway. So even if you spend all your resources, just make sure that these activities are performed sequentially. The equipment will still be subject to wear and tear under normal degradation curve of that particular assets. And the fun part is why we are so comfortable with this maintenance for its safety and security, or what I might call the lazy man's approach to maintenance. It is actually burning a lot of cash in terms of unnecessary maintenance. Okay, so there are so many unnecessary maintenance that we do because it is time. Okay, and that's one disadvantage from this. That disadvantage is what the predictive maintenance strategy seeks to resolve. The predictive maintenance strategy is an attempt to not just perform the maintenance activities on a schedule without thinking about anything else, but instead to monitor the asset's condition on a schedule. So predictive maintenance is also called condition monitoring. Condition monitoring. While preventive maintenance has routine maintenance activities, predictive maintenance uses routine maintenance, data logging, routine maintenance inspections, and so on and so forth. It's a data-driven approach for evaluating equipment condition on an ongoing basis. Most of your critical and complex equipment should fall under this category. For example, your high tension panels, your transformers, your control panels for sophisticated systems, for example, should work. You should adopt the predictive maintenance approach, which means you are collecting data that helps you to indicate whether the asset is working within its operating parameters. Every asset you have, especially heating and cooling, moving parts assets, they have parameters that the manufacturers have set. Take your generator, for example. There is a temperature range for normal operations. There's an oil range for normal operation. There's a vibration range. There is a pressure range. There is a sound range, you know, and so on and so forth, right? So all of these ranges are what you want to ensure that as you are monitoring and gathering data, you are seeing that your operating parameters are staying within the range of each parameter. Now, why is this called predictive? The way you monitor each parameter, when that data begin to tend towards it going outside its control limits, you can now, one, predict how long you have to this failure, or how long you have to it going past that upper or lower limit that is been specified. Then, two, you are now also able to make plans on how to diagnose or troubleshoot and fix while the equipment is still in use, because you know how much time you have. And as such, you can provide a solution that meets, that corrects or prevents that problem from becoming a breakdown, because you are watching the parameters and you are taking action that is not necessarily a preventive maintenance approach, but a plan to react before it fails. So if you want to put the three strategies in a comparison, in reactive, you let it have a fault. In predictive, you don't let it have a fault. You use your sear stone or your looking glass in terms, you know, which is what you are doing by gathering, analyzing data. And that sear stone or looking glass, that is the interpretation of the data that you are getting on each operating parameter of the asset, is predicting when it will likely have a fault. And because you are seeing that you will likely have a fault, you can fix that problem before the problem is a problem. So you track for signs and symptoms, you fix those signs and symptoms, and you never get the core problem. That's what predictive is doing. And if you want to relate this again to the human body, when you fall ill and you go to hospital for treatment, as your main body maintenance strategy, you are operating a run to failure strategy for your body. Okay? I do nothing about my body until I feel really terrible. I have to go and see a doctor or a pharmacist to get a drug. That is run to failure. Okay? If I take a certain anti-malaria drug, for example, every week forever, just to make sure that I don't come down with malaria, I am adopting the preventive maintenance strategy for my body. If I then adopt a strategy of doing a regular body check, I have my oximeter for checking my oxygen level, I have my counter for checking my pulse level, my heart rate, and all of that, and I do a blood test every week, for example, to check how much parasite of malaria is in my blood, I am adopting a predictive maintenance strategy. Okay? Maintenance is not carried out based on predetermined dates, but based on the actual condition of the equipment. It implies that the maintenance is performed at the ideal time and resources not wasted on unnecessary work. Convenient scheduling of maintenance activity is made possible by predictive maintenance. In terms of cost relationship, predictive maintenance will be the cheapest. It's 1 to 5 to 10 compared to comparing predictive, preventive, and corrective. But this result was arrived at with engines, with equipment with moving parts. This will not be the case for your roof, for your civil and structural components, for example, your windows and doors. Okay, so that's just some kind of caveat, because there are some of these components we have in our facilities that we really can't even use predictive or preventive for. We have to use run to failure and understand the difference between all of them. So what are the things that we use to gather all this data? What helps us do the analysis? That's what we are saying here. Mostly sensors that read temperature and feed this information into the dashboard. You have meters that records flow rates, that records all kinds of metrics. You have thermography that measures temperature, since warming up and cooling or continuously warming up, that takes it above the temperature operation threshold of that operating parameter, and so on and so forth. These are things you typically see in some sophisticated equipment, like your generator that has a very big computerized panel, for example, and you see all of these spindles and graphs, showing up on the screen on how the generator is operating, is because there are certain sensors that have been placed within the gen at different points to read vibration level, temperature level, and so on and so forth, back into that main screen that you are seeing. That is predictive maintenance. So when you take all of this data and you're not using it to make decisions, you are not doing predictive maintenance. You are only doing predictive maintenance if you are doing analysis of data, collect accurate data, analyze those data, and use those data to act in such a way that your equipment don't break down because you know when it is likely to break down. Why do you use predictive maintenance? Of course, it helps you to plan and schedule for corrective maintenance. So while the run to failure it's failed, it's broken, I need to fix it. The predictive is I want to make sure that it doesn't fail. Okay, I want to prevent unplanned failures. I'm also able to negotiate my parts purchases. I'm also able to plan my resource allocation so that I don't have to spend too much or move people from operations into these because it's an emergency, like we used to say. And then I can be sure that my equipment will always be available and reliable because I'm tracking, I'm knowing when it will be likely out of use. So I reduce disruption and I know when it's going to have a problem. The advantage of predictive maintenance includes the fewer breakdown, reduce equipment downtime, increase in production, more proactivity because you are monitoring the data. Some of the disadvantage includes high initial startup costs because you have to buy all of those sensors and all of those meters and analyzing tools and software. Sales potential are not readily seen because you're spending upfront. Management may not necessarily see how this is going to cost you less. Especially if you're not a very experienced facility manager who can make judgment calls that can be trusted. And then, of course, you're going to invest in diagnostic equipment and in staff training. You can't have this run-of-the-mill roadside technicians managing your assets when you're doing predictive. They cannot wake up and put down numbers for you in those spreadsheets. They have to be actual numbers that you can trust because your maintenance program can really be messed up. All right, the reliability-centered maintenance. The basic philosophy of RCM is that decisions on maintenance activities should be based on the system's maintenance requirements supported by economic and technical premise. So in essence, this is where we now bring in economics into maintenance. We want it to be reliable, but not at any cost. That's what RCM comes to do. Combination of more than one maintenance strategy. That's why I say it's a portfolio approach. It takes a system approach. So I can have my HVAC system, I could have my electrical system, I have many assets that make up that system. And then each of these assets, I apply a different strategy depending on the maintenance lifecycle view, process long-term approach to that maintenance, evaluate the root cause of failures, periodic evaluation of maintenance activities, and all of the other maintenance procedures that goes into it. So it's a framework. That's why it's not a strategy. It enables the determination of a complete maintenance regime, and that includes all of your assets, and it's a way to, and that's why until you start doing a complete maintenance plan, not just the preventive maintenance plan, you cannot be talking about reliability-centered maintenance. It's a broader view of maintenance, and it gives you that framework. But what does it really, how do you really apply ROCM? You group your assets, or you assign strategies based on certain criteria you would have set using ROCM. For example, I'll put all the small parts and equipment, non-critical equipment unlikely to fail and redundant systems under reactive or run to failure or corrective strategy. Anyone that is subject to wear, moving parts, a lot of friction, I'll probably put under the preventive maintenance strategy. Or the ones that consumes a lot of consumable parts or components. Equipment with known failure patterns. Equipment that you know that something wears out that you have to remove and refit. Or a filter accumulates dirt and after a while it becomes clogged, right? So these are known failure patterns. And in many instances, preventive maintenance is what your manufacturers will easily recommend. Do this at this time and you have peace of mind. That's what they will easily tell you for most of the equipment that fit this category. Then if you are under obligation to do that, you have no choice than to assign that strategy of preventive maintenance to that particular equipment. The equipment or assets that should be put under predictive maintenance: random failure patterns, critical equipment, not subject to wear, equipment or systems which failure may be induced by incorrect preventive maintenance. I've seen some FMs go ahead, open their transformers because somebody is looking for a job. You give him a contract to come and maintain a transformer that is working perfectly. He opens it up, does one or two activities, recouples it back, and the transformer never becomes the same again, begins to have issues. Okay, so if you have equipment that, if I go ahead to maintain this asset, I might make mistake or something can go wrong with the assets, I'll leave it. I'll leave it on predictive. I'll just be monitoring it, checking on its condition, taking temperature, taking all that sensor data, just to make sure that I don't mess things up. When you look at the advantages and disadvantages of reliability-centered maintenance, it's very similar to that of the predictive maintenance. Why? Because predictive maintenance is expected to give you the least cost. Okay, the least cost. And ROCM is really about spending the least amount, but not sacrificing reliability. All right, so that's our class for today. You have an assessment in this class that is due on Thursday. Yes. So I'm going to allow you to ask your questions now. Let's take a 3 to 5 minute break, and then you can put your hands up, and then we'll talk about the questions you have, okay? Okay, let's get back to it. So if you finish reviewing your notes, let me see your hand up so that you will be given the mic to speak. Questions or comments? Okay. Are we overwhelmed or underwhelmed? Why are we not having any comments? Which one? Which one? Tell me, are we overwhelmed or underwhelmed with this class that nobody's asking questions? You could be, you could have understood it so well that there will be no need for questions. But if that is the case, then tell me something that you have learned that is new to you. Okay, finally, one hand is up. Temitope, go ahead.
Good afternoon, sir.
Good afternoon.
Okay, so sorry. Like I said earlier in this class, this lecture, I think it's actually for me personally, because I haven't listened to the maintenance, the reactive, preventive. My organization has a big name, but the methodology of working is just very poor. Very poor. I mean, extremely very poor. Because right now I discovered that I have to do a lot of damage control. Like for example, they have a tractor now, and he's already having a serious downtime, and then the management is looking at, oh, because this thing was not budgeted for, then we cannot pay for it. And yet you are intending to sack the person that is in charge of that activity. And the man said, see, I told you that servicing is different from maintenance, different from repairing. All I gave you budget for was for
routine maintenance, yes.
And he noted under his report that this maintenance cost is without repair.
So where's the repair plan? Where's the repair plan? I'll fire him if I were his manager as well.
Because he told them that since he is not so conversant with many of the parts, and he may develop problems without being so, like for example, he's having problem with nozzle, he's having problem with the injector, he's having problem with propeller, and he said all these things after thorough inspection, they were all intact. The injector suddenly developed a fault, which he doesn't even know until an expert was contacted.
Yes, to come and check it.
Come and check. He said, now how do you expect me to budget for what I don't even have an idea that is inside the tractor?
It shouldn't say that. Every asset you manage, you must understand what we call the failure mode of that asset, right? You must know every moving component within the asset that can fail. You can't be telling me that, oh, I'm managing a chiller system and the chiller system is working well. How do I know the parts of a compressor or a capacitor or something in that air handling unit? I need to know the components of each of the systems I manage. It's just a lazy mindset to be in charge of an asset and not look deep into the asset enough to understand what you're managing. When we're doing the asset management class last Saturday, and that's why I keep stressing, FM should not be trying to separate themselves from asset manager. You are the asset manager at the time that thing is under your custody. And because of that, you must understand what the asset is made of, what can go wrong with that asset. You must know the market prices of those things, not after they've broken down. There's no way you can keep creating a preventive maintenance program and ignoring reactive cost budgeting. What then is your budget? You must budget for everything. That era where FMs go cap in hand, doing memos and trying to justify a spending out of budget is long gone. And FM should be able to envisage, anticipate, estimate, forecast all the unplanned downtimes and failures that will come your way. You have a conference room, 100 chairs in that conference room, and you have not been keeping data for the 5 years or 10 years that conference room has been there. How many chairs have broken down every year, and what components of it? Is it the seat? Is it the legs? Is it the handle, handrest that have been breaking over the time? How many of them have been replaced? How many are there now from the 100 we started with? Those kind of data will help you predict how many armrests and how many rollers you should plan for next year, next 2 years, next 3 years. How many of those chairs should be replaced next year, next 3 years? You need to have a way of using data to model and forecast what's going to happen next. You need to put something down for management to see that you have an idea of what might likely happen. Don't say, oh, it's an act of God. It's never an act of God, never an emergency.
Okay. All right. Maybe after this, I'm going to have a proper call with you, because the essence is without, let me put the best way, it's without any FM facility.
Yeah.
What they do is not to say, okay, you handle this, you handle that part, you handle that part. So there is no overall coordination.
Yes.
And it was in my process of complaining to someone who has said about 4 or 5 people to Max-Migold. I said, okay, you see, forget about all these your masters and these nepos. Just come to this class, then you'll be able to advise Banana Island very well, very well. And of course, I have gone through about 4 classes now, and at the end of every classes, I just keep shaking my head. I said, man, there is a long way to go. There is a long way. I was speaking with the GM today. I said, sir, he said, what? I said, I want to recommend a class for you, Max-Migold. He said, after 35 years of experience, I said, if you have experience, this kind of discussion that I'm bringing to your table will not go. Like, for example, if this guy is going to be sacked now, he's going to be sacked because he presented an asset management and what he feels he knows how to do best, but there was nobody to checkmate what he has done. To say, oh, okay, give me an idea of what can be damaged, what can be repaired, cost effectiveness. Nobody. I said, should we now sack him now based on his failure or based on organizational failure?
I see. I agree with you perfectly on that. So I think if we don't give people the proper strategic training, they will fail. And if they fail, it's the organization that has failed at that point. So I think you and I need to meet and talk at some point so that we can see what kind of intervention we can bring on ground, because an FM's framework needs to be developed holistically that will guide everybody's program, and they will all lead to the same end result of reliability for the assets that you manage. So I think we should talk offline on that, yeah?
Thank you.
You're welcome. Franklin.
Hello, good evening, all.
Good evening, welcome.
It's been an interesting class, and it's an offshoot of our last class of Saturday, where we talked about asset register. So what I understood from this class is like, okay, in my own company, we always know that we are the asset manager. We are the maintenance officers of our assets, and we schedule the maintenance and the repairs. Now, I got from the other class that having an asset register, which is actually not on ground, right? I've not been able to do that in my own didn't importance of that last class, and it's very necessary. I've already started getting information on the asset to work with here. Now, it does not just end in getting that asset register. It also goes a step further to categorize all the assets according to the type of maintenance they will require. Whether they will be predictive or preventive or run to failure. So that would be the last of it. That is the RCM.
Yes.
So it's very necessary that as we do the assets register, we should be able to, in advance, plan, just as we are just advising now, in advance, plan of what type of maintenance they will require, so that we should be able to capture that at the beginning of the day, in advance of the time. Not just every time, because as you rightly said, about 90 to 100% of the generators, as we know that the generator will be due for servicing in so and so run hours. Every other asset mostly run to failure.
And you need to plan for them as well.
Necessary that we should be able to do that now and categorize them under this segment, be able to capture that. That is the sort of what I'm taking away from the class. Thank you.
Fantastic. Thank you very much. Ibukun.
All right. Good evening, sir.
Good evening.
Yes, I just want to ask all the strategies that we have. Are they all supposed to be documented? I just want to confirm that. Then secondly, we have preventive maintenance plan as part of the project to be doing. So that seems to capture that's talking about the second one, I want to believe, out of the one we discussed today.
Yes.
So, but how come we don't have for the others?
Yes,
it seems to place more priority on preventive.
Yes, so that is what I'm teaching that we need to change. So by the time I'm sending you the project docket, I'm going to make sure that the maintenance plan reads maintenance plan, not preventive maintenance plan, so that you will be focused on your entire asset register in making your maintenance plan, so you can budget appropriately for your maintenance. Okay.
Okay. So that means the maintenance plan rather will capture all of our assets.
Every asset must be your maintenance plan. Yes. Every asset you own and
must
manage
be documented there.
Must be inside it, yes. And each one must be assigned a strategy.
Okay. Great. Thank you.
You're welcome. Adebowale, go ahead, please. You're muted. You're still muted.
Good evening, everybody.
Good evening. Welcome.
Yeah, hi, Mr. Paul. I've always had this strong backup for preventive maintenance, because I feel probably it has worked for me, but today you changed my mindset, and I really want to give me more reason why you're changing my mindset. Because if I've always embraced the preventive maintenance, it means that I've been guiding for that fault not to arise on my assets. So if I'm doing a preventive maintenance, I must have seen that, oh, this Kickstarter for this particular plant wants to knock off. I would have seen it before time, and I would have been able to correct it before it happened.
That is predictive. That's not preventive.
Okay.
Because if it is preventive, I will be going there to oil it, whether it's giving me sign or not. I'll oil it when it's time to oil it. I'll grease it. I will tune it when it's time to tune it, based on a program that is fixed. That's preventive. But if I'm always watching it, using sensors to get data, watching the symptoms on a regular basis, and when I see that it's tending towards a failure or a fault, I take action to prevent it from failing. That is predictive maintenance, not preventive maintenance. Predictive maintenance is the only maintenance strategy that takes a look at condition monitoring, that takes a look at checking for signs and symptoms of failure that has not yet happened, but will happen because of what you're observing. Whereas in preventive maintenance, you are not observing. You just come there and you do the routine activity that has been scheduled.
So that means the predictive and the preventive, they are so
close. Yes, they are so close. So that's why I actually chipped in during my lesson that Sometimes we take all this data for generator. You record the temperature, you record the oil level, you record this, battery head level, you do that. I am recording all these things. You're not using that data for anything. When it is 250 hours or 300 hours, you come, you change the oil, you didn't test the oil, you change the filters, you don't check whether they are still okay to run another 50 hours, for example. You just remove them and put new ones. That's preventive. Whereas if I'm doing predictive in that case, I will check the oil. If the oil can still do extra 60 hours based on the viscosity, dissolved metals and other parameters of the oil, it meets the operating parameters for oil for that thing, I will leave it, I won't touch it. I will check the filter, I will check the pumps, I will check this, I will check temperature during normal operation. If it stays within, I will just record my observation and see that everything is within the parameters. I won't do anything. That's predictive maintenance. So the data will be helping me decide when to act or when not to act. So the data has to be accurate for predictive to work.
Okay, thank you.
You're welcome. All right, thanks everybody. Have a good evening. You have enough time to do the assessment rather. Please get into it right now before you get up from your desk. Otherwise, you may not submit it by Thursday afternoon. All right, bye-bye.
Bye, and thank you for a beautiful class.
Thank you very much. My pleasure. Bye.